Okay. Another problem. We have problem 27. A stockroom worker pushes a box with mass 11.2 kilo on a horizontal surface with a constant speed of 3.50 meters per second. So the coefficient of kinetic friction, because it's moving, the coefficient of kinetic friction is given between the box and the surface is 0.2. So, again, usan niyo mapapansin, for you to understand the static and the kinetic, is that mas mabugat ito sa kabutang pag diri nakiwa. Because again, your usual value for your static friction is static coefficient is bigger than your kinetic friction. So that's how you can understand more on the coefficient of friction. So static is for those that are not moving and kinetic is for those who are moving. Whether it's first law and second law. Even though it's moving in the first law, again, you have an acceleration is equal to 0, then your velocity is somewhat constant. Okay? Friction between the box and the surface is a point 2. What horizontal force must the worker apply to maintain the motion? So, A muna. So, maybe I can draw it. So, karoy ko kasi hindi ako mas-screen. Dako ko lang agi. I don't know. Sige daw, I'll try. Dako ko agi. May nareklamo actually nga. But ko agi. We can just draw the box. So, that is, you have a box. Then what's the problem says? You have a 3.50 meters per second. So, velocity is equal to 3.50 meters per second. And then to maintain, of course, you have a friction here. So, there must be a friction because the static of kinetic friction is given. So, you have a friction there, which is kinetic friction. Okay? Ano pang ginawa? You have a friction there, and then because your kinetic coefficient is given to be a point 2. Of course, you also have a normal force there because you have an equation for normal force and the frictional force. And then, of course, you have a weight of this box that is 11.2 kilograms. 11.2 kilograms. So, problem, ano yung problem natin? 3.50 meters per second. What horizontal force? So, and then you will have a horizontal force to maintain this motion. So, therefore, your force must be this side. Okay? So, meaning, since this is first, is you should notice that this problem is about equilibrium because to maintain that velocity. Because if you will not, again, your velocity is not a force. The force on the axis is frictional force and this force F. If you will take this out, you will only have a frictional force acting on this box. Meaning this velocity would be 0 at a particular time. Because it would decelerate. Because your summations of forces which is equal to ma, it will now be ma if this force will not counter this frictional force. See? So that's how you analyze that one. So this one is a summations of force x is equal to 0. Maybe we can plug our equation because this is a case of equilibrium. So your forces to the right is somewhat F to the right. Again, forces to the right while forces to the left is somewhat your frictional force F. Okay? So meaning, and then you have to find that F. So you only have to find that frictional force, but you don't know that frictional force unless you go to your equation for your Fn. Meaning your F actually from the kinetic standpoint that is fun, mu and then n normal force. But again, you still don't know the n, so you resort back to summations of forces on y. Okay, the summations of forces on y is also equal to 0. It's not that there's no acceleration. Yes, there's no movement on the y-axis. There's a movement on x, but there's no movement on the y. Therefore, it's still 0. So again, there might be cases that you have a acceleration on x, but you don't have any movement on the y. So that is first law on the x, I mean, second law on the x, and first law on the y. And it usually happens. Okay, so bear in mind of what you're doing. So summation of Fy, because you don't have a movement to the y, so what is going up is of course your normal force, and what is going down is of course your weight, which is equal to mg. So this mass multiplied by the gravitational pull. There's no other force, so N is equal to W, which is equal to mg. And then you can substitute of course your N on this side. Therefore you can say um, that your the force is equal to F, and that F is equal to Mu's kinetic N, and that Mu's kinetic N is equal to Mu's of kinetic mg. So that frictional must be Mu's mu k mg. So substitution, so you have mu sub k, which is 0.2. You don't have a unit for that. 0.2, and then your m is 11.2 kilogram, and then your acceleration to gravity is 9.80665 meters per second squared. So that will give you your constant force F that you should do to have that constant velocity. Not acceleration, but equilibrium, which is constant velocity. First law says that a body at rest will always be at rest, and a body in motion will be in that constant motion. And this is it, in constant motion, because of that your F. But again, your summations of force, the F you applied versus the frictional force, which is actually equal but reverse, the action-reaction pair. Um, okay, they are equal. 2 times 11.2 times 9.80665, and you have 220 into significant figures. 220 kilograms, that would be 200 Newton. So I'll cut it here so that it won't be too long. Thank you guys for listening. Okay, so part B of problem 27. If the force calculated in part A is removed, how far does the box slide before coming to rest? So that's what I've been explaining a little while ago, that if that F will be removed, see, if this will be removed, the summations of forces on X will only have this one. So you can have now summations summations of force, is letter B, summations of force which is equal to ma now, because again there will only be one. Summations of force would be equal to negative F, because that is going to the left, which is there's no other force. So basically this would be ma. This would create an acceleration. That would be equal to ma. Okay? Mass times acceleration. So you can calculate what's the problem, how long, so how far. So you're asked about how far, so you should resort to kinematics equation, which is equation number 3, I think. Let's go back. um, Equation 3, you have a velocity. Yes, you have initial velocity, you have a final velocity. um, yes, you have a final velocity, and it would be zero. Why? Because it will stop. Diba? That's what the problem says. You look, remove how far is the box slide before coming to rest. So it would be at rest. So you can use equation number 3. I think Vx squared is equal to Vo squared plus your 2a, and then your distance x minus xo. But again, this one is the distance actually. So without the negative sign, so that should be the distance. If ever the negative, so distance is the scalar quantity for that. So this one would be 0. So you will be solving 2a, and then maybe you could just put distance is equal to negative Vo x squared. So 2a, and then you can have a, which is negative VO squared all over 2a, and then substitute it here. So summations of force is from your still your summations of Fy will still be the same. So this guy over here, your frictional force is equal to mu k, or here equal to mu k mg. Your frictional force would still be valid because that's from your of course F is equal to F is not valid, but your F equal to mu k of n and mu k sub mg is still valid because your n and mg is from your summations of force on y, which is still the same, meaning first law. So you can have now F, which is negative F is equal to ma. Then I can substitute here negative mu k mg is equal to ma, and that is m. So you're talking about the same box, so that would cancel out, and then you have a negative VO squared all over 2D, sorry, 2D, 2D, okay, 2D, and then you can solve the D here. You can cancel this D, then out the M, then you can have D, you can cancel the negative, of course, then you would have a VO squared all over 2 times mu K and then the G without the negative. So substitution, that would give us how much? 3.50 squared meter squared per second squared all over your 2, and then your kinetic coefficient of friction, which is zero point 0.2, and then your 9.80665 meters per second squared. So second squared cancel, one of the meters is being cancelled, so you would have a unit of meters. So that would be 3.50 squared all over your 2 times zero point 0.2 times 9.80665, and that would give us, voila, that is 3.1 in two significant figures. I think we need two significant figures for this one, depending on the problem. So the problem gives you three significant figures, so it should be 3. So the answer is 3.12 meters. That would be the distance. Okay, because I could just correct my mistake. I think I've multiplied not point 0.2. So 0.2, 11.2, 9.8, actually that should just be 22 newtons. Okay, so 22 newtons. So that is 0.2, then about here, so that is 3 point, so 3 significant figures, that's 3.12. Okay, thank you guys, isumpay ko lang.